So there's kind of this weird amount of cooperation within conflict in a lot of species. So competitors will actually signal to one another. There will evolve this system of signals by which nobody has to get hurt. Even stranger in it, sort of to our eyes, is the sort of conflict that happens between close relatives. And this kind of conflict is, it can be very subtle, it can be very complicated, and it can be very weird. You would think, after all we've been talking about kin selection, about individuals helping one another reproduce, that organisms would always want to help their close family members. But this is not always the case. One of the areas where this comes up the most is parental care. Usually, or I shouldn't say usually, I should say frequently, there is conflict between two parents about how much each parent ought to invest in an offspring or brood of offspring. For example, here is a male finch. He has a nest. He has sired these 5 little baby birds that desperately want food. If he helps them get food, they are more likely to grow up to be adults and pass on his genes. On the other hand, so parental care increases the fitness of the offspring, and so it increases the indirect fitness, the indirect reproduction of the male. However, foraging for worms takes time, it takes energy, it takes nutrients. Maybe he's going to get killed while he's foraging for food. And all of this energy, time, nutrients, and risk, these are all resources that could be invested in another brood of offspring, either in the future, in terms of risk, or right now. That male could run away and find another female and mate with her and have more eggs. The only way that he can stay here and hunt for bugs for these is if he gives up this opportunity. So the opportunity he has to go and reproduce elsewhere, is a cost that he has to pay in order to help these offspring. And it's the same thing for mom over here. Here's one thing that makes it tricky in this particular case. There is a certain payoff that comes for both of the parents from this nest. Some number of individual baby birds are going to survive and pass on the genes of both parents. But how many doesn't just depend on what the father is doing. How many doesn't just depend on what the mother is doing. The payoff for this father partly depends on what the mother is doing, and the payoff for this mother is going to partly depend on how much care this father is providing for the offspring. So you've got a really complicated situation here. And what you're going to end up with is both parents are going to co-evolve. In other words, essentially the genetic strategy followed by one parent is going to change. It's going to evolve based on the strategy that the other parent is genetically programmed to carry out. There can be a number of different outcomes to this. At some point, the two investments co-evolve and find some kind of stable equilibrium. They reach a point where each parent is carrying out the best strategy for them given what the other parent is doing. Okay, so for example, there are some species in which, males could, if they left their current crop of offspring, they could have many, many more offspring somewhere else. That means that there's a big cost for investing in this crop of offspring. That favors less investment in the current crop of offspring. This male is going to be more likely to go off and invest time and energy and risk having other broods of offspring. The problem is that reduces the probability that these individuals are going to survive. Well, that's not good for her, and so what may happen is that she, who has very little gain by leaving, will invest more in this crop of offspring so that more of them will survive and she'll maximize her own fitness. Well, it could be that because the female is taking care of these offspring, that favors a male that is even less invested in helping them survive because she's already taken good care of them. And so the males evolve to invest less. The females have to, the females have to compensate for that by investing more. And you end up in the stable equilibrium where one of the parents, in this case the male, doesn't help at the nest at all. He fathers the offspring and leaves. Okay, and if the cost of parental care is much higher for one parent or the other, then the parent for which the cost is high may just offer no parental care at all. And this is the case in a number of bird species. The offspring are only raised by the female. That's not the only equilibrium that individuals can come to, though. If there's a difference between the cost that individuals pay by staying and helping this batch of offspring, then one of them is probably going to help more than the other. But they're both still helping. It's just that the amount of help they're providing is unequal. And if there are low costs or high benefits for both individuals to help this crop of offspring, what evolves is social monogamy. Males and females pair off and they stay with one another. Neither one sneaks off and tries to have another clutch of offspring with some other mate. So the outcome, when you have two parents co-evolving with respect to the level of care that they're putting into a single brood of offspring, depends on a few things. One is the question, what does each parent give up in order to provide parental care? If that is high for a particular parent, that parent is likely to opt out of caring for the current group of offspring. It also depends on how much each parent's contribution affects offspring fitness. If, for example, one parent can provide all the care that a group of offspring needs, then usually in those species, the offspring get parented by only one parent. And that's usually the one that pays a bigger cost, or sorry, that pays a smaller cost for staying around and helping. The reason that the other parent, the one that would pay a greater cost, is free to leave is because that wouldn't reduce that individual's indirect fitness. If one parent can provide enough help, then there's no point in hanging around and being the second parent who is providing food and protection for a nest of offspring. Finally, one thing we haven't talked about, and this throws another interesting variable into a lot of things, is that females know whose offspring they have in their nest. They know that those offspring are theirs. Males are not necessarily as sure. They can't be 100% certain that the offspring in the nest are theirs. If a male is very sure that he has been the only male that has been near this particular female since she became receptive to mating, then natural selection favors an individual in that case to invest more in that group of offspring because basically it's 100% certain that the same genes are in that individual, or those individuals, sorry, those babies. In species, though, where females might mate with many males, natural selection is much weaker when it comes to favoring males' investment in parental care. And that's because the male might actually be helping to raise offspring that aren't his, that do not have the same genes. So a gene that causes a male to help the offspring might actually not be passing itself on. So this is pretty complicated. But what you need to know about is sort of how each one of these factors in isolation affects the amount of parental care that each parent is likely to invest. There's another kind of conflict within a family that we should consider. It's the conflict between parents and their offspring. We are a species that invests a tremendous amount of care, time, energy, and sometimes risk in taking care of our children. And so we tend to think of parents as being very doting and loving, of basically having the exact same interest as their children, at least when it comes to their survival and reproduction. This is not actually the case, though. In particular, what a parent essentially sees when they look from a genetic perspective at their offspring is they can see 50% of their genes in each one of those offspring. In other words, they have a significant stake in the survival and reproduction of each of those offspring, because each one of those offspring, each one of those lion cubs, is carrying half of this lioness's genes. And so her genes should have evolved so that she takes care of those lion cubs. However, she is equally closely related to a bunch of other lion cubs, and those are the cubs that she has not yet had. What this means is that she wants to invest in her current offspring to keep them alive and to reproduce, but she also wants to keep some resources aside so that she can invest in future offspring. And this may mean that she doesn't want to spend all of her nutrients or energy on the current crop of offspring, but most often what it means is she does not want to risk her own life to save her current offspring, if that would mean risking all of the future lion cubs that she might have. And the variable that really matters here is how many offspring are at stake in the future. If you've got a female who is young, is likely to survive for many years, is likely to have lots and lots of offspring, then she's going to be relatively unwilling to risk her life to save these current offspring from, say, a predator that comes by trying to attack them. The reason is that if she were to lose her life, she'd lose all of these future offspring. In contrast, a female that is very old, is basically near the end of her reproductive life, if she lays down her life to save these cubs, as long as she's successful, she hasn't actually lost anything, because she wasn't going to reproduce in the future anyway. The upshot is that older females, females with less of a reproductive future, tend to engage in more risk to protect their current young. And actually this goes for organisms of both sexes. This is because reproductively, individuals that aren't going to reproduce again really have nothing to lose.